Welcome! This video will bring you through an exciting adventure on robust speech emotion recognition with representation learning and multitask learning. Due to the time limit of this video, we will leave the details in the report and only go through the high-level features of this project.
Kids are talking by the door.
What you have heard is an audio file from the RedDef dataset, which contains short English speeches. Let's hear another one.
Kids are talking by the door.
In speech emotion recognition, or SER, the aim is to develop a model that is able to recognize that the first audio carries the emotion of happiness and that the second audio carries the emotion of fear. In this project, we hope to develop SER techniques to recognize emotions in audio with high accuracy. As you might have already known, this project deals with SER, but it dives deeper into SER. The first part of this project is to find robust representations of the speech signals that are invariant to the gender of the speaker. The second part of this project is to use the gender information to improve SER in multitask learning settings. Lastly, the third part of this project introduces two novel techniques, class-based and recentered CAR data augmentation and selective accelerated learning SAL. Both techniques significantly improves SER scores. We will first deal with the first part of our project objectives. We will describe one technique that could be used to generate robust representations of speech signals. This technique is called the Supervised autoencoder. Our experimental setup has two components. The first component is the Supervised autoencoder, which is also our model. The job of the Supervised autoencoder is to generate robust representations of the speech signals. The second component is the simple classifier, which is simply a simple fully connected neural network with one hidden layer, and is shown on the right. The job of the simple classifier is to evaluate just how robust the representations generated by the Supervised autoencoder really are. The representations of the speech signals generated by the model comes from its hidden layer. Our aim is to make the hidden activations or representations in this autoencoder hidden layer to be as invariant to the gender of the speakers as possible. I have yet to explain what the Supervised autoencoder is. Let's go through it briefly. The Supervised autoencoder is simply an autoencoder with a source-max layer attached to the autoencoder hidden layer. First, we have the input layer, which is the breadth features. The breadth features is just the input features generated from the speech audio signals. Then, we have the hidden layer, which is an autoencoder layer. Finally, we have the source-max layer, which predicts the emotion classes. One key distinct feature of the Supervised autoencoder is that while we are training the autoencoder hidden layer to learn the encodings of the breadth features, we require the encodings to perform well in the source-max layer at the same time. This is achieved by having a joint cost function of reconstruction loss and supervised loss. With the Supervised autoencoder, we are able to significantly outperform the baseline model, which is just an autoencoder. Other than the Supervised autoencoder, we have other techniques to generate gender invariant representations of the speech signals. The techniques include independent loss, triplet loss, etc. Their results are displayed here. The second part of this project is to use gender information to improve SER in multitask learning settings. One multitask learning or MTL technique that we developed is called gender information capitalization. In this technique, we first split the training set into two subsets. Subset 1 will contain speeches by female speakers, and subset 2 will contain speeches by male speakers. Then, we make use of two separate classifiers to train female and male instances separately. Thus, we have the female model and the male model. We then manipulate the weights in the two models so that both models will be able to handle male and female instances equally well. Gender information capitalization MTL resulted in significant improvement over the baseline model, which has not employed any MTL technique. Other than the gender information capitalization, we have other MTL techniques in this project. The techniques include cross-stitch MTL, SUS, network MTL, etc. Their results are displayed here. Lastly, the third part of this project introduces two novel techniques: class-based and recentered CAR data augmentation and selective accelerated learning SAL. Both techniques significantly improves SER scores. Due to a technology disclosure submission, we are unable to provide details of these two techniques. The results of using both CAR and SAL are displayed here. Our results outperform the state-of-the-art for EmoDB and RedDef datasets. Thank you for your attention, and we hope you enjoyed this video.